Now then, what have we got today? We've got some year 12, which is probably why I'm in a good mood, because it's a lot less effort than the year 13 stuff. So I've got Edexcel May 2019, and then it's the AS Mathematics. So today we're going over paper 1, which is pure. Let's absolutely destroy it. So question 1 says, the line L1 has equation 2x plus 4y minus 3 is 0. L2 has equation y equals mx plus 7, where m is a constant. Given L1 and L2 are perpendicular, find the value of m. Alright, so let's get in. So perpendicularity, or whether things are parallel or not, it's all in the gradient, right? Look at the equation of L2. It's y equals mx plus 7. Compare that to y equals mx plus c. What is m? M is the gradient, isn't it? So perpendicular gradients multiplied together to make minus 1. So the gradient of L2, which is m, multiplied by whatever the gradient of L1 is, must equal minus 1. So what is the gradient of L1? We'll call it m1. What we need to do is we need to rearrange the equation for L1 in this form, y equals mx plus c. And then we can just read it off, can't we? So what I'll do is I'll stick the 2x and the minus 3 on the other side. So I'll be left with 4y. I've never seen this before, so I'm absolutely going in cold here. Equals minus 2x plus 3. I suppose that's not an excuse for not even being able to speak though, so what am I on about? Divide by 4, yeah? So I get y equals minus a half x plus 3 over 4. That tells me that this bad boy here is m1. Therefore, minus a half, which is m1, times m equals minus 1. Cancel the minuses, I get half m equals 1. Multiply by 2, I get m equals 2. Not too shabby. The lines L1 and L2 meet at the point P. Find the x coordinate of P. Okay, so lines meeting, or curves meeting, whatever, it's simultaneous equations, isn't it? So I've got two equations here, haven't I? You know what? I'm going to use this thing here, because I already nicely rearranged that for y. So L1 has the equation y equals a half x plus 3 over 4. L2 has equation y equals mx, but we know m to now be 2. So 2x plus 7. So, you can write them in any form. I like this form just because if I have a y equals and a y equals, it's a really easy way for me to just basically eliminate y from these equations. So if y equals that, but y also equals that, then surely that must equal that. Therefore, a half x plus 3 over 4 equals 2x plus 7, and I just get x now. So if I was to add a half x here, I'm going to be left with 5 over 2x, I believe, here, plus 7, and then I've still got this 3 over 4 here. So just whatever you want at this point. You might want to get rid of the fractions. You might want to just stick that over there and divide by 5 over 2 and stick it all into your calculator. Really doesn't matter. Let's multiply by 4 just because. So if I multiply this by 4, it cancels the 4 here. Multiply 5 over 2 by 4, I get 10. X plus 7 times 4, which is 28. If I now take 28 from both sides, I'm going to get 3 minus 28, which is minus 25, is 10x. Therefore, x equals minus 25 over 10. Now, we want the x coordinate. Luckily, we're not going to have to sub this back into y, so, let's just simplify, right? 5 goes into both of them, so this is going to be minus 5 over 2. Question 2. Oof! Bit of an equation on the go here, haven't we? Okay, we've got 16a squared equals 2 root a. I'm going to make a mistake here. Tell me if you find it. Okay, so 16a squared is equal to 2 root a. I'm going to rewrite this root a as a half, okay? So a to the half, that makes sense. And now, well, I've got a bit of a common factor here, haven't I? So I've got a to the half and then a squared, but a to the half goes into that. So if I divide everything by a to the half, I'm going to get 16. Then if I have a squared over a to the half, that's a to the 3 over 2, right? I take the powers away. And then the a to the half here is going to cancel. Okay, sick. I'm now going to divide by 16. So I'm going to get a to the 3 over 2 equals 2 over 16, but that's 1 over 8. Okay, so what you would generally do here is you would get rid of this. So if I was to, for example, do both sides to the power of a third here, I would get an 8 to the third here. A third is just a cube root though. So an 8th to the third is the cube root of 1/8, which is a half. And then multiplying these powers, these 3's cancel, don't they? That's why I did that. So this is just going to be 8 to the half. And now I square both sides because that's a square root. So this is just going to give me a equals a half squared, which is a quarter. Done. Where was the mistake? This all looks pretty legit, does it not? And everything here is okay. This is all legitimate maths, and a equals a quarter is a solution. The problem lies in this thing here. I cancelled down a to the half, okay? I divided both sides by a to the half, and then I got the only solution is a is a quarter. But look at this equation. What would happen if a was equal to 0? Surely 16 times 0 squared, which is 0, is the same as 2 times 0 to the half, which is also 0. So 0 satisfies this equation. So what have I done to just lose this solution? It's the fact that I divided by something and I didn't account for the fact that that something might be equal to 0, because it's unknown, isn't it? So it could be 0. So you've got two options here. The first one is to just put everything over to one side, and instead of dividing by a to the half, factorize it out. And then you'd have like two things multiplied to make 0, and then you can say, that is 0 or that is 0. Second thing, because I've already done this, is you can basically say, okay, well therefore, that or a to the half is 0. If you acknowledge the fact that, in another situation, the thing I'm dividing by could equal 0, but I'm going to take care of that here, then it's okay to do everything I just did on the left. You've essentially now just got two sets of equations, haven't you? On the left, that gives me this solution, and then this one here gives me this solution. So I have two solutions to this equation. A is a quarter and a is 0. Fantastic. What does part B say? It's a hidden quadratic. It's just basically a hidden quadratic. Get really used to kind of noticing these. Essentially, if I was to rewrite this as b squared squared plus 7b squared minus 18 equals 0, if I was to just, let's say, y, anything you want, equals b squared, what would this equation become? It would become y squared plus 7y minus 18 equals 0, which is a quadratic. So this is a hidden quadratic, isn't it? You need to find it. I can factorize this, can't I? So if I was to do y plus 9 and y minus 2, I think that'll do the job, right? Because I get 9 minus 2, 7, 9 times minus 2 is minus 18. Okay, this would lead me to two solutions, wouldn't it? It would lead me to y equals minus 9 and y equals 2. Am I done? Well, no, I'm not, am I? Because this is an equation in B, and I've just given you y, which is just this thing I've made up. So I need to now get b back in there. So I would then get b squared equals minus 9, or b squared equals 2. This has no solutions. And before all you further maths nerds go on at me, right, and you say, no, imaginary numbers, we're only looking for real solutions to this equation, okay? So within the real numbers, there are no numbers that square to get minus 9. So that, no solutions. Second one, I square root both sides to get b equals plus minus the square root of 2. Question 3, integration already. Oof! Given that k is a constant, find this. So with integrals in year 12, you really want to express all of these different indices just in the form of x to the power of something. So if you have a square root of x, be like, what's that as a power of x? Or if you have a divided by x cubed, think, what is that as a power of x? So in this case, I'd have the 4, and then that would be x to the minus 3. And then plus kx, and I just need to work this out here. So add 1 to the power, divide by the new power. So add 1 to this, I get minus 2, so I'm going to have a 4x to the minus 2, divide by the minus 2. Kx is like k to the 1, right? So if I add 1 to the power, I would get x squared. Did I say k to the 1? X to the 1, you know what I mean? Divide by the new power, so divide by the 2. Am I done? Come on, man. You're too good for that. Okay, part B. Find the value of k such that all of that stuff. So the difference between the integral in part A and the one in part B is that part A doesn't have limits, right? It doesn't have limits here, so it's indefinite. The one in part B is definite. So in other words, I have the same thing, right? But with these limits. And then, this thing here. Now, we've already done the kind of integration work in part A, so we don't need to think about that again. So basically, just whatever we have here, we're then going to have in our square brackets of definite integration. The limits are going to go on the right now, and I just have this thing, right? So, you know what? Part A, it says simplify your answer. So probably I wouldn't have got full marks for that, because I should simplify this a bit, shouldn't I? So essentially, this is a 4 over minus 2. So I'll take the minus outside. 4 divided by 2 is 2. And then x to the minus 2 is basically the same as divided by x squared. Can't really simplify that at all, so let's just put that as like a half kx squared plus c. Okay, now hopefully I've got the marks. Sweet. So yeah, going back to part B, whatever's in here is just going to be this, but you don't need a plus c in a definite integral. I have explained that in another video, can't really be bothered going through it now. So all we do here is we just sub 2 into this, sub 0.5 into this, and we should be laughing. So the first bit is going to be minus 2 over 2 squared plus a half k times 2 squared. And then minus a big old bracket with me subbing 0.5 in for x. So minus 2 over 0.5 squared plus a half k times 0.5 squared. My handwriting is so bad. So just work it out. All of these little individual bits, use your calculator if you want. I'll just see if I can work them out. But again, absolutely nothing wrong with using your calculator. Don't worry. So 2 squared is 4. So I get 2 over 4, which is going to be a half. So this is minus a half. 2 squared is 4. So I get half times 4, which is 2. So I'll get plus 2k. Minus 0.5 squared is a quarter. So I'll get 2 divided by a quarter, which is going to be 2 times 4, which is going to be 8. Again, 0.5 squared is a quarter, so I get half times a quarter, which is 1 over 8. Lots of k. Sick. Now, what should this thing be equal to? We're told that this whole integral, when I put the limits in and everything, is equal to 8. Therefore, I can set this thing, because it's equal to that thing, equal to 8, right? So now let's just see what happens. Let's keep this here. So I get a half minus a half plus 2k minus 8, so plus 8, minus 1 over 8k equals 8. And I hope you can see the nice thing here. I have this 8 and this 8. Take 8 from both sides. They cancel. So I'm going to be left with 2k minus 1 over 8k. Well, 2k is what? 16 over 8k. So take 1 over 8k, I'd have 15 over 8k. Again, don't think you need to do that in your head. Don't worry about it. If you want to do that in your calculator, just do 2 minus 1 over 8 and you'll get it. So 15 over 8k, that's my k terms. This has gone, this has gone. I need to put this over to the right-hand side, so I'm going to add a half. Cool. Multiply everything by 8, I'm going to get 15k equals a half times 8, which is 4. Divide by the 50. K equals 4 over 50. Nice. Question 4. A tree was planted in the ground. Its height, h meters, was measured t years after planting, and then it tells you 3 years later it had this height, 6 years later it had this height. Using a linear model, find an equation linking h with t. Okay, so this might not be immediately obvious, actually, what you need to do. What would linear model mean? So obviously model is like, okay, well, we're trying to model or come up with some mathematical equation that relates, the height, h, to the time, t. So that says, oh, after 4 years or whatever, the height will be this. So that's what a model is. But then the question is, there's loads of different equations in this world. How am I going to choose what type of model? Would it be exponential? Would it be trigonometric? Would it be logarithmic, etc.? In this case, it says linear. Okay, so if we want the height as some function of t, right? That's the model bit. If that function has to be linear, what would it look like? Well, linear, think linear line, straight line. What's the equation of a straight line? It's y equals mx plus c, right? So it's basically going to be, in this case, almost like h equals mt plus c, right? That's almost like a y equals mx plus c. H equals mt plus c. So that's a linear model. Now, I've not actually got the values of m and c yet, so that's not really proper, but I've got some information that may help me get those values. So we're told that when t is 3, right, 3 years after planting, the height of the tree is 2.35. Could I not therefore say that 2.35 is equal to m times 3 plus c? I reckon so. So what's that? 3m plus c. Again, I've still got two unknowns, so I've not really got enough information here, but I've got another piece of information there, which says 6 years after planting it was 3.28. Therefore, I could say that 3.28 is equal to 6m plus c, and I could call that equation 2. Simultaneous equations, right? So if I was to take equation 1 from equation 2, the c's would cancel. So if I was to do 2 minus 1, what would I get? I would get, on the left-hand side, I would get 3.28 minus 2.35. And on the right-hand side, I would get 6m plus c minus 3m plus c. 6m minus 3m is 3m. C minus c is 0. 3.28 minus 2.35 is not something I'm going to do in my head. It is 0.93. Therefore, m is just going to be 0.93 over 3. So if I do ants divided by 3 here, I'm going to get 0.31. Fantastic. Am I done? No, because I need to see. Sub it into whatever you want. Why don't we sub it into equation 1? So equation 1 would now imply that 2.35 equals 3m, so 3 times 0.31, plus c. So c is going to equal 2.35 minus 3 times 0.31. Sick. 0.31 is still my ants, so if I do 2.35 minus 3 ants, that should get me c as 1.42. Therefore, my final answer here would be what? It would be my linear model that tells me the height of this tree after a given amount of years is h equals 0.31t plus 1.42. Cool. What does part B say? The height of the tree was approximately 140 centimetres when it was planted. Explain whether or not this fact supports the use of the linear model in part A. Okay, so once we have this model, we can start thinking about kind of relevant quantities here. Because I could say, okay, well, this is t years after it's planted. So what would the model predict that my initial height of this tree was when it was planted? What value of t would I need to sub in? 0, right? 0 years after it was planted was when it was planted. So if I say this, if I say, look, when t equals 0, the model would say, the model says that h would equal 0.31 times 0 plus 1.42. Well, surely that's 0, right? Meaning I'm just left with 1.42. Now, what is h measured in? It's measured in meters. So the model predicts that the initial height of this tree was 142 centimeters, right? And we know that the true initial height was 140 centimeters. So I think that's pretty good, don't you? Like, that's only 2 centimeters off. True height was 140 centimeters and model predicted 142 centimeters. So, I mean, it's pretty, like, reliable, isn't it? So, well, does it support it? Yes. Definitely supports it. So, supports the model, essentially. So, yeah, just think about how the real-life information that you just got given relates to this mathematical model. 5. A curve has equation y equals 3x squared plus 24 over x plus 2. Find dy by dx. So just the same as a couple of questions ago when I was talking about when we integrate, it's much better to write it, if I have I think we had an over x cubed, and I said, write that as an x to the minus 3. It's the same thing with differentiation. This 24 over x, it would be much easier to differentiate it if we wrote it as 24x to the minus 1. So I've got my plus 2, and now dy by dx is quite simple, just using bringing the power to the front, taking 1 from the power. So bring it to the front, I get 6, take 1 from the power, x to the 1, which is x. Bring this to the front, I get minus 24, and then I get x to the minus 2. This is like x to the power 0, so bringing the 0 to the front, it goes. That's literally, no, again, finding its simplest form. It could be argued that that's its simplest form, but I reckon they probably want you to write the second term as that. They probably, don't like these kind of negative powers here. So I reckon that's what they're after. Cool. Hence, find the exact range of values for x for which the curve is increasing. So, curves, right? Essentially, this is a curve, does all of this stuff. What does increasing mean? Well, increasing means the curve is going up, right? So where is this curve increasing? Well, it's increasing kind of from here all the way up to here, right? Because it's going up. It's then decreasing here to here because it's going down. And then here onwards, it's increasing, isn't it? It's going up. So what do the going up or increasing parts have in common? If I was to draw a tangent at any of these points, the gradient of said tangent would be positive, right? All positive lines. If I was to draw a tangent at the decreasing bit, it would be going down. It would be a negative gradient. So how do I get the gradient of this curve? Well, I do dy by dx, don't I? So when this curve is increasing, we know that dy by dx must be greater than 0. So to find the x values for which this is the case, all I need to do is set my derivative, which we know to be this here, greater than 0. Cool, so this is an inequality that we need to solve. We always need to be mega careful with inequalities. There's a lot of tricks. The first trick with inequalities is if I multiply or divide by a negative number, we need to flip the sign. So a classic way that people remember that, okay? But then they'll get an inequality like this, and they'll go, oh, multiply by x, sweet. But how do you know that x isn't negative? If x was positive, that would be correct. But if x was negative, then I'd have to flip the sign. So it's just a madness, isn't it? So always think about that. If I multiply an inequality, think, wait, is that positive, etc. It would be nice if I would get rid of this fraction here. Now, I can multiply by x squared here. Why? Because x squared is a squared number. It's always going to be positive, never going to be negative. So I am allowed to do that now. If I multiply through by x squared, I'm going to get 6x cubed minus 24 is greater than 0, and that is okay. Add the 24 to both sides. 6x cubed is greater than 24. Divide by 6, that's all legal. X cubed is greater than 24 over 6, which is 4. And am I allowed to cube root? I am, because think about it, cube roots doesn't change the sign at all, does it? Like if I have a positive number and I cube it, it stays positive. If I have a negative number and I cube it, it also stays negative. So cube rooting is okay. Square rooting, you got to be careful. Cube rooting is fine. So basically, x must be greater than the cube root of 4. Question 6 brings us a cheeky triangle, okay? So it's got some x's, it's got some unknowns in the lengths, but this should be fine. Gives us the area of the triangle, find x. So essentially it's just saying, look, what is an equation that you can create using the information that the area is 18 root 3? Well, the area of a triangle is equal to a half AB sine C, where C is the angle in between the two lengths AB. So we've got exactly that here, haven't we? Because this 60 degrees that we're given is in between the 2x and the 3x. So basically, this is just going to be a half times AB, so the product of the two sides. So 2x, 3x. C is going to be the 60. And then we are told that this is equal to 18 root 3. Sweet. So, okay, a half times 2x is just going to be x. So I get x times 3x, so that's going to be 3x squared. Sine 60, you can put this into your calculator, but it happens to be root 3 over 2. So I think I'm in a good spot here, aren't I? Because the root 3's are going to cancel. And then what I can do is, why don't I divide by 3 here? So this is going to get me x squared over 2 equals 18 over 3, which is 6. Multiply by 2. X squared equals 12 square root. So x is going to be the square root of 12. Why do I not need a plus minus here? Because x is clearly a length. Not x itself, but like 2x and 3x. So if x was negative, 2x would still be negative, and that wouldn't make sense, would it? Can I simplify this? Yes, because 12 is 3 times 4. 4 is 2 squared, so that is going to be 2 root 3. Sick. Hence find the exact length of BC, giving your answer as a simplified surd. So we can use the cosine rule here, because if you look at this triangle, essentially the cosine rule is the following. 2BC cos A long. So here, A, this little a, would be our unknown length, in this case this kind of BC, and then, you know, B and C would be the 2x and the 3x, the angle A would be the 60, you just stick it all in, essentially. So A squared is going to be B squared, so 2x all squared, plus, see, you know what, we know x now, don't we? So instead of doing another line, I'll just put it in here. 2x, if x is 2 root 3, is going to be 4 root 3. 3x, if x is 2 root 3, is going to be 6 root 3. Minus 2 times b times c. So b is the 4 root 3. Woo, what's kicking off here? 4 root 3 times the c, which is 6 root 3, times cos a, so cos 60. So there's a lot kicking off here, isn't there? Just stick it in your calculator. You could individually work everything out, but there's no algebra here, is there? So this whole thing is just some number. So if I was to do the following, get a bracket and then do 4 root 3 all squared. I missed out the power there. Here we go. This is a lot of calculator work. Plus 6 root 3 all squared minus 2 times 4 root 3 times 6 root 3 times cos of 60. I hope this turns out to be nice. I get that as 84. Seems okay, right? So therefore a would be the square root of 84. Can I simplify this at all? Probably. Stick it into my calculator. That's going to be 2 times the square root of 21. Question 7. The curve C has equation y equals k squared over x plus 1. K is a constant. Sketch C stating the equation of the horizontal asymptote. Right. Okay, there's a bit kicking off here. Now, here's what I recommend and what I tend to teach on AI Tutor. You need to know, or it is a great idea to know, I kind of call them base graphs, right? So for example, in this case, the base graph would be y equals 1 over x. That's the thing that just gives this thing the general shape, okay? So if I was to have y equals 1 over x, I would basically teach you, look, remember that this looks like this. This kind of makes sense, right? Because as x gets massive, 1 over x is going to get really, really tiny and go to 0. As x gets close to 0, y is going to go close to infinity. So we get these asymptotes on the axes at this point because x can't be 0 here and y can't be 0. So what we're going to do is we're going to learn our base graphs and then we're going to learn about graph transformations. Because then if you have a base graph and you know about graph transformation, you can do any graph that is kind of formed from this. So what would happen if, for example, I changed this 1 to some positive number? If I change that to a 10, it wouldn't really change what this... It would change the graph if you were to like plot this with a computer. The numerical values would be different, but the general shape of this would be no different, because this would correspond to a stretch in the y-axis, right? But because this just kind of goes all the way down to 0 up to infinity, if I was to stretch this, the general shape and the general main attributes of this graph would not change at all. So if it was negative, it would change slightly and it would kind of flip around like this. So here's the thing, look at what we have. We're told that it's k squared over x. So I think what they're doing with the fact that it's k squared is basically them saying, look, they need to clock that this is going to be positive here, isn't it? If it just said k, and it didn't tell us that k was specifically positive, there would be no way for us to know if it was like this or like that. But because it's k squared, it's going to look like that. So this graph here is going to look like that, okay? So now the only transformation is we add a 1 to it. So if we just add a 1 to a graph, it just takes the graph and adds 1, right? Because it's like y value, I'm adding 1 to the y values, which is the vertical values. So all I do is I just grab it and I just put it up by 1. So that would go up, and then this would also go up like that. That is it, okay? So now think about where these asymptotes would be. It used to be the case that at 0 it couldn't be 0, but now I'm moving this graph up, so my asymptote is now going to be it's going to be 1 upwards, isn't it? It's going to be all the way here. So this is the line which it goes infinitely close to, but never hits. This asymptote going up here hasn't changed at all, has it? Because all I've done is I've added 1 to the y coordinates. I've not done anything to the x coordinates. So the graph would essentially look like this. What would now be the equation of the horizontal asymptote? That's going to be this horizontal line here. That's going to be y equals 1, isn't it? This jobby here is going to be y equals 1. That is the equation of this horizontal line. Cool. So the line L has equation minus 2x plus 5, well, y equals that. Show that the x coordinates of any point of intersection of L with C is given by a solution of the equation, all of that stuff there. Okay, so again, intersections, it's simultaneous equations. We already have y equals k squared over x plus 1 here. All I now need is the other one, which is y equals minus 2x plus 5, and we can solve them simultaneously. The good news here is that, again, we've got y equals and y equals, so we can just set them equal to each other. So I would get k squared over x plus 1 is equal to minus 2x plus 5, solve. Multiply up by x, because we don't like fractions. So I'm going to get k squared plus x equals minus 2x squared plus 5x. Looking to be a bit quadratic, is it not? Stick it all onto one side. Let's put this over here. I'm going to get 2x squared. And then I've got an x here, and I'm going to take 5x from both sides. I'm going to get minus 4x. And then I've literally just got this k squared now, haven't I? Plus k squared equals 0. Is that the answer? It is. I can still do maths. Part C, okay. Hence, find the exact values of k for which L is a tangent to C. Okay, so let's have a think. Let's have a think. This equation down here is telling us where the intersections of this green graph is and my line is. So my line could, for example, look like that. In this case, it would have 2 intersections. It could, for example, it could literally be that line, in which case it would have no intersections, right? Because the graph never hits it. In this case, we are told that it is a tangent to C. What would that look like? Well, tangents, remember, they just skim by the graph at one point and then go off again. So look at this. That's a tangent. Or it could maybe be this. Think about all of these tangents. They only intersect the curve once. Draw me a tangent here that intersects the curve more than once. You're not doing it. So here's the thing. The fact that this is a tangent means that the curve and the line only intersect once. That es muy importante because, right, so let's write it down. Curve and line only intersect once. Why is this useful? Because we have an equation here that tells me, you know, once I solve this equation, this is going to tell me the x coordinates of the intersection points. So here's the thing. If I now know that they only intersect once, I must know that this equation here only has one solution. So this equation here only has one solution. Equation above only has one solution. So what do you know about quadratic equations and the amount of solutions they have? Well, it's this old chestnut, isn't it? It's the discriminant. So the discriminant, which is the b squared minus 4ac in any quadratic, if this thing is equal to 0, it implies that the solutions of the quadratic, there's only one of them. There's only one solution of this quadratic. So that's what we have in this case, right? You know, the steps of logic is tangent, one intersection, one solution of the equation. Therefore, if I just take these here, this is going to be A, B, and C. Now I've got an equation on my hands that's just going to have k's in it. So b squared is going to be minus 4 squared minus 4a, so 2, times c. That's equal to 0. Solve it. We should be laughing. So this is going to be 16. This is going to be minus 8. K squared equals 0. Take the 8k squared over to the other side. Divide by 8. And square root, which is going to get k equals plus minus the square root of 2. Question 8 says find the first 3 terms in ascending powers of x of the binomial expansion of that thing there. Cool. So the good news is we only need 3 terms, okay? So with a binomial expansion, you basically need to... So by the way, this is in your formula booklet. The thing that they give you in the formula booklet can be quite confusing when you just look at it. It's just a pretty grim looking algebra. So essentially I'll go over like what the binomial expansion, how we do it. So this term here, we've got 2 different terms. The first one is a 2, second one is a 3x over 4. Basically, the powers of the 2 is going to start at the top, so 6. So I'm going to have a term that basically is like 2 to the power of 6. And then corresponding to that, I'm going to have 3x to the 4, but to the power of 0, essentially. And then what's going to happen is they're both going to go like this. So this powers of 2 is going to go down, and then this is going to go up. So my first term is going to be some 6 lots of 2 and no lots of the other thing. I'm then going to have 5 lots of 2 and 1 lot of the other thing. Because think about it, every term, if I had 6 of these brackets, there's a product of 6 things, isn't it? So it's just a combination of like how many 2's are you getting and how many 3x over 4's are you getting. So that's going to be to the 1. And then the last term here is going to be what? 2 to the 4 corresponding to this squared. So now the full binomial expansion would go all the way till that goes to 0 and that goes to 6. But I only want the first 3 terms here. So I can write plus ... to show that I realise that this thing isn't exactly equal to that. There's a bit more kicking off. So note that the powers always add up to 6. 6, 0, 5, 1, 4, 2, etc. It's not quite the whole story because we have these things called binomial coefficients. Like this doesn't only happen once. There's loads of different combinations. There's different ways that I could get 5 2's and 1 lot of 3x over 4. So that's where this kind of NCR stuff comes in. Kind of like this. I like to write it like this. Some people might not. That kind of looks like a vector. I write it like that. But essentially, you can get these from your calculator. And what's going to happen is the top number is always going to be 6. And then this number at the bottom is going to go up from 0 to 6. So the first term will have a coefficient of 6c0. Second will be 6c1. 6c2, etc. Note how this number is always the same as that power. So at this point, we can just shove it in our calculators and start simplifying, really. So I'll show you how to get the NCRs. So to get 6c0, I'll literally write 6. And then on most calculators, above the divide, there'll be a little thing that says NCR. So press Shift Divide, it gives you the C. then you write the number at the bottom. So in this case, 6C0, which would be 1. So that would be 1. And then I would do 2 to the 6. Let's work out what that is. It's 64. So I'm going to have 64 here. And then that's a power 0, so that's 1 as well. Let's work this out. So 6C1 is going to be 6. So I've got 6 times 2 to the 5, which is 32, times 3x over 4. Last term. 6C2, let's work that out. That's going to be 15. Times 2 to the 4, which is going to be 16, times all of this squared. Remember to square the whole thing. So it's going to be 3 squared, which is 9, x squared, which is x squared, 4 squared, which is 16, and then plus dot, dot, dot. Last line, let's just simplify it all. So 64, I can't simplify at all. 6 times 32 times 3 over 4x. Work out what the number is in your calculator and then just shove an x on it. So if I was to do 6 times 32 times 3 over 4, I'm going to get 144. So I get 144x here. Same thing here. Do 15 times 16 times 9 over 16 to get me 135. Lots of x squared. That'll do for part A. Part B says explain how you could use your expansion to estimate the value of 1.95 to the power 6. Oh, you don't need to perform a calculation. That's nice. So look at what we did in part A. We worked out what some bracket, the bracket looks grim, but whatever this bracket is, to the power of 6. And then we have 1.925 to the power of 6. So in part A, we have this. And then in part B, we have 1.925 to the 6. Surely it would be very useful then if this thing here was just equal to that, right? Because then if that's the case, so if 2 plus 3x over 4 was equal to 1.925, then I could find the x value, which makes these two things the same, and we could say, oh, sweet. Then that x value, I can sub it into there, and I can get an estimation for this. So if I was 2, let's just work out what x is here. So let's take 2 from both sides. So I'm going to get 3x over 4 equals 1.925 minus 2 times by 4 divided by 3 to get that. Let's work out what this is. 4 over 3 times 1.925 minus 2 gets me minus 0.1. So to do this, all I would need to do is I would just sub x equals minus 0.1 into my expansion. Because that would be the x value that makes the thing inside the bracket 1.925. Fantastic. A company started mining that sweet, sweet Riverdale tin on the 1st of January 2019. A model to find the total mass of tin that will be mined by the company in Riverdale is given by the equation T equals 1200 minus 3 minus 20 squared. T tons is the total mass of tin, n years after starting mining. Sweet. Okay, so this thing's quadratic and it is already incomplete in the square form for us. We're probably going to have to do some stuff related to that. Calculate the mass of tin that will be mined up to the 1st of January 2020. Well, look at n. The n is, it starts on the 1st of January 2019, right? And then n is the years after 2019. So 2020 is 1 year after 2019. Therefore, n would just be 1 in this case. So that's all I need to do. I just need to sub n is 1 into this equation. 1200 minus 3 times 1 minus 20 squared. Calculator time, innit? So 1200 minus 3 bracket 1 minus 20 all squared, 117. Not too bad, right? So that would be 117 tons in this case. Part B, that's the one that comes after A. Deduce the maximum total mass of tin that could be mined. Why is it incomplete in the squared form? Because it is super useful, right, to see what the maximum value is. Look at this, okay? Look at this bracket. I don't care what n is. I don't care what's inside the bracket. The bracket is squared, okay? So I've got... I forgot to speak. You know what? I'm rolling. One cut. So this is going to be positive because it's already going to be squared. 3 times a positive number is a positive number. So essentially, this mass is going to be 1200 minus some positive number. Well, if I want to maximize the value of t here, surely I don't want to take anything away from this number, right? I don't want to take away a positive. I want this to be as big as possible. So this is going to reach its max value when this thing is just 0, because that's the smallest value that can be. So if that is 0, then the maximum amount is just going to be 1200 minus 0, isn't it? Which is 1200. So the maximum amount is going to be 1200 tons. Not too crazy. And that's why completing the square is so useful. Part C. Calculate the mass of tin that will be mined in 2023. Surely we just sub in... that will be mined in 2023. Okay, that's a good question, actually. Because this formula gives us the total mass, doesn't it? So 2023 corresponds to the 5th year. So you might be fooled into thinking, oh, you just work out what t is in the 5th year. But that would get us the total amount of tin that was mined up to that point. So that would be the 1st year, 2nd year, 3rd year, 4th year, and 5th year. So think about the years, right? 1, 2, 3, 4, 5. I just want what was mined here. If I work out T5, that's going to get me what was mined in all of this. How do I just get the 5? Well, if I work out T4, that'll get me everything here, wouldn't it? So if I want just this, all I would need to do is T5, which is the yellow line, minus T4, which is the green line, which just leaves me with the red, doesn't it? So let's work this out. At this point, I mean, that's the kind of tough bit of, understanding there. At this point, it's just sucking numbers in, isn't it? So it's just going to be 1200 minus 3 times 5 minus 20 squared. That's T5. Minus 1200 minus 3 times 4 minus 20 squared. Work it out. So, I mean, you know what? Before I go into my calculator, I can clean things up slightly. I'm going to get a 1200 minus 1200, so they're going to go. That's going to be positive, so you essentially have positive 3 lots of 4 minus 20 squared, and then minus 3 lots of 5 minus 20 squared. That should sort us out here, so let's work it out. So 3 times 4 minus 20 all squared minus 3 times 5 minus 20 all squared. That gives me 93. Should be okay, so it's going to be 93 tons. And the last part, state giving reasons the limitation on the values of n. Okay, so let's have a think. Look at this equation for t. It's a quadratic, and it's a negative quadratic. I don't care exactly what it looks like, but it generally... A negative quadratic is going to look like this, isn't it? And we know what this maximum point is going to be. We kind of deduced that in part B. It's related to the fact that the maximum point is when this n minus 20 is 0. So that is going to be when n equals 20, right? And then that happens to be corresponding to t is 1200. So that's going to kind of be the coordinates 20, 1200. So this makes sense, right? Like n is going up here. N is increasing. So obviously, n is going up, I spend more years mining the tin, I'm going to be getting more tin. The amount n increases, the amount of tin I mine increases, obviously. But then look what happens when we get to n equals 20. It's going to start going down. So that doesn't really make sense, does it? That would say that for n equals 21, you will have mined less tin in total than you had mined 1 year ago, which just doesn't make sense because the total amount of tin mined can only go up. So basically, n is just going to have to be less than or equal to 20 here, isn't it? Because it works, right? It's an increasing function for n values up until 20, but then after that, it starts just not making sense. Sick! That's done! Question 10. A circle C has equation x squared plus y squared minus 4x plus 8y minus 8 is 0. Find the coordinates and the radius of the circle. Okay, so in general, the nice equation of a circle is x minus a squared plus y minus b squared equals r squared. This is nice because if a circle's in this form, we can just read off the centre, which is AB, and the radius, which is r. So if we can get this thing here into this form, we're laughing. So what we do is we complete the square. I've got an x squared and an x term. I complete the square on those, separately complete the square on the y terms. So x squared minus 4x is going to be x minus 2 squared minus 4. Y squared plus 8y is going to be y plus 4 squared minus 16. Still got the 8 chilling on the end, and then that's going to be equal to 0. Clean it up now. So I've got x minus 2 squared plus y plus 4 squared, and then I'm just going to send all the numbers onto the other side. So adding them to the other side, it's just going to be all of these added together. So 4 add 8 is 12, add 16 to that, I get 28. That therefore tells me that the centre is going to be 2 minus 4. It's always the opposite of this sign, right? So centre is going to be 2 minus 4. And then the radius is going to be the square root of 28. Remember that the right-hand side is r squared, so the radius is the square root of that. Can I simplify this? Yes, because that's 4 times 7, which is 2 root 7. Cool. Part B says, the straight line with equation x equals k, where k is a constant, is a tangent to c. Find the possible values for k. Okay, so there's a couple of questions ago, actually. There was a question related to this. It said, find the value of k for which this line is a tangent to this curve. And what I said was that, I think the curve looked like this. And I said, if there was a tangent to this curve, then there's only going to be one intersection. Therefore, the discriminant of the equation where I'm trying to find out this intersection is going to be 0, because there's only one solution. So we can do that here. However, I think it can be even simpler. The reason is, we've got a circle, right? We know that its centre is, where's the centre gone? 2 minus 4. And the radius is 2 root 7. Okay. So I've got an equation here of a line, x equals k. When I have a straight line that's just x equals k, there's no y term, what does that look like? It's going to be vertical. So it's just going to be a line going up like this. So here's the thing, the only way that this line here, this just straight vertical line, can be a tangent to this circle is if it's right on this edge, or if it's right on this edge. So I don't even need to do any discriminant stuff here, because I can use something that's even simpler. For this, possibility, what would the x-coordinate of this be? It's not that difficult to work it out, because I know the x-coordinate of the centre, and I know the radius. The radius is 2 root 7, isn't it? So what would the x-coordinate of this be? Well, if this is 2, this is going to be 2 minus 2 root 7, right? So the first value of k is 2 minus 2 root 7. But then what would the other possibility be? Well, the other possibility is if it's here, right? And what would that be? Well, 2. And then again, this distance is 2 root 7 again. So that would just be 2 plus 2 root 7. So my two possible values of k there are just 2 plus minus 2 root 7. Question 11. Prove that x minus 4 is a factor of f of x, where f of x is this cubic, right? Factor theorem, you know how to do this. All you need to do is sub in the x value that would make this bracket 0. So what would make x minus 4 0? It would be if x was 4, right? So all I do is sub in f equals 4, x equals 4 to f, and hopefully this thing is going to equal 0. So just shove it in, put it in your calculator, you should be okay. So 2 times 4 cubed minus 13 times 4 squared plus 8 times 4 plus 48 is 0. Who would have thought it? And then you'd give it a little Therefore, x minus 4 is a factor, all of that fun stuff. That will do the job. Okay, so what does part B say? Hence, using algebra. It's a weird thing to say, using algebra. Show that the equation f of x equals 0 only has two distinct roots. Okay. It would be nice if we could fully factorize f of x. So one way to do that is we could do algebraic long division, right? So if I divide x minus 4 into this cubic, I know it goes into it because I've just shown it's a factor, right? So then we're going to get the other bit that's left, and it should be some quadratic. So if I was to do this, x minus 4, and then the cubic, so 2x cubed minus 13x squared plus 8x plus 48. Then what I can do, let's do the long division. I'm not going to go through super detail how to do this, but there are other videos for that if you need them. So how many times does x go into 2x cubed? 2x squared. Multiply this through, so I'd get 2x cubed minus 8x squared. Minus them, so minus 13x squared minus 8x squared will be minus 5x squared. Put it in, so how many times does x go into minus 5x squared? It would be minus 5x. Multiply it through, so minus 5 times x is minus 5x squared. Minus 5x times minus 4 is plus 20x. Now this, I've still got this stuff kind of from down here. Take them away. That cancels. 8x minus 20x is going to be what? Minus 12x. Again, how many times does x go into minus 12x? Minus 12. Times it through, so minus 12 times x, minus 12x. Still had a 48 here, by the way, and then minus 12 times minus 4 is 48. Cool. There are videos on AI Tutor and loads of different examples of this if this confuses you. Okay, what this tells me is that my cubic can be expressed in the form f of x equals x minus 4 times this. So 2x squared minus 5x minus 12. Why is this useful? Because if I was to solve the equation f of x equals 0, I now just have the equation this equals 0. So factorizing it is useful because when I have factors multiplied together equals 0, I can split them up. I can say, sweet, that means that either x minus 4 equals 0, which implies that x equals 4, so I've got a solution there, sweet. Or this stuff equals 0. 2x squared minus 5x minus 12 equals 0. Now, if I was to solve this, it's a quadratic, I can go on and solve it. This, however, says that it only has two distinct roots. So, I could potentially show that the discriminant is equal to 0. Why would that work? Because for f of x equals 0 to have two distinct roots, I know that there's one root here. That would mean this would have to have one distinct root. So if I can show that that has one distinct root, i.e. the discriminant is 0, then that would show that f of x equals 0 has two distinct roots. So what I could do is I could... So there is a potential, actually, that this would have a solution of x equals 4, meaning that there would only be two distinct real roots that way. I'm not sure. Why don't we just solve this? See what happens. So why don't I just put this into my calculator, okay? So if I go to menu and then go down to equation func, polynomial degree 2, because that's a quadratic, put my coefficients in. So I'm going to get 2 minus 5 minus 12, and then go answer. Yeah, okay, I think that's what's happened. So I get my first value of x as 4, and then my second one is minus 3 over 2. Yeah, that makes sense. So it's not the fact that that has one distinct root, it's that it's got two distinct roots, but then one of them is the same as that one. So in total, my x values are just going to be 4 and minus 3 over 2. Cool, so there's a couple of different ways that can happen there. Part C says, deduce, giving reasons for your answer, the number of real roots of the equation, this. Okay, so there's going to have to be some relationship between what we've already done and that, okay? So the first thing is we've been shown an image of f of x, okay? So we can clearly see why that has two distinct roots. It hits the x-axis twice, right? It hits one of them down there at minus 3 over 2, and then it has this repeated root at x equals 4. And then it says, deduce giving reasons for your answer, the number of real roots of the equation, this. So what is this function? Well, the x cubed term is the same, the minus 13x squared is the same, the 8x is the same, but where f of x has a plus 48, this has a plus 46. That's the only difference, right? So my function, we could maybe call it g of x, is just f of x minus 2, isn't it? It's exactly the same as f of x, but it's just got 2 less on the end, so it's minus 2. What would minusing 2 from a function do to its graph? It pulls it down by 2, doesn't it? So let me absolutely botch what this curve looks like. So the f of x that they've given us, are you ready for an absolutely awful sketch here? Here we go. Here we go. It's quite hard to do it with this pen. That's the best you're getting. So this is f of x, right? If I was to now sketch y equals g of x, in other words, f of x minus 2, what's going to happen? Well, basically, it's going to be exactly the same as f of x, but just plonked down by 2. So by 1, 2. It's going to go down like that, isn't it? So we can clearly see here that if we were trying to solve the equation g of x equals 0, that would just be an equation where is this graph equal to 0? So we can clearly see that this has 1, 2, 3 solutions, can't we? So, you know, what I would say, I would do something like that. I'd give that little sketch, why not? And then I could just say something like, you know, the graph of g of x, or which we can also call f of x minus 2, you know, hits the x-axis 3 times. Something like that. With that graph, that is more than enough for the examiner to go, yeah, I suppose they know what they're on about, don't they? Sick. Part D says, given that k is a constant on the curve with equation y equals f of x plus k passes through the origin, find 2 possible values of k. Okay, so let's get rid of this g of x sketch here. We're just working with the f of x. First of all, y equals f of x plus k is a transformation, is it not? So y equals f of x plus k corresponds to a translation in the x, okay? And then we need to remember that it's with the x transformations, it's always almost like the opposite of what you think. So if I add k here, that actually means I'm taking away k from the x values. So in other words, it's going to shift it to the left by k. So think about it. Obviously this doesn't go through the origin. What would I have to do with a horizontal shift to make it go through the origin? Well, there's 2 options, isn't there? The first one is that I'm pointing with my finger, you just can't see that. This bit here is going to move to the left, so it just touches the origin. So what would that correspond to? What have I done to that? Well, we know that this is at 4, isn't it? So for me to get that to move through the origin, I need to move it to the left by 4. So that would correspond to k being equal to 4, because this here is the graph of y equals f of x plus 4. But there's one more way, isn't there? And this is about to get really messy. But essentially, what if I was to do the following? The other way, this is f of x, is if this one moved to the right. So if this moved to the right, then that would also go through the origin, wouldn't it? So where is this? This is at minus 3 over 2, I believe. So what would I have to do to the graph to make it go 3 over 2 to the right? Well, k would then be, remember it's always the kind of opposite, so going 3 over 2 to the right actually corresponds to a minus 3 over 2. And they are the 2 possible ways that this translated graph could go through the origin. Question 12, what we got? Show that, all of that grim looking stuff. It shouldn't be too bad, you know. The reason is, in year 12, there's only 2 trig identities that we use. We use the fact that cos squared plus sine squared equals 1, and that tan is sine over cos. So with some combination of these, we're going to get our answer, and that's guaranteed. So there's not loads of options for us, really, is there? So what am I looking at? I'm seeing I have a sine squared, right? But then everything else is in cos. The right-hand side that we want to get is in cos as well. So I reckon it's probably a good idea to swap out the sine squared for, what would we swap it out for? Take cos squared over here, I'd get sine squared is 1 minus cos squared. So let's do that. So instead of writing 10 sine squared, I'm going to write 10 times 1 minus cos squared. Is this a theta? This is a theta. Minus 7 cos theta plus 2, all of this stuff. Just clean up the rest, right? 3 plus 2 cos theta. Okay, clean up the top, see what we got. We're going to get 10 minus 10 cos squared theta minus 7 cos theta plus 2 all over 3 plus 2 cos theta. And then what we're going to get here, we're going to get 10 plus 2, so we're going to get 12. And then we've got 12. So this is a quadratic, isn't it, actually? So why don't we write the cos squared term at the front? So I'm going to get minus 10 cos squared theta. And then I'm going to get minus 7 cos theta. And then plus 12. And then over all of this stuff. So it would probably be useful if I could factorize this and hope that one of the brackets is 3 plus 2 cos theta. That would actually sort me out, wouldn't it? So should we try and get that to work? So, okay, let's try and factorize this. If I have a 3 plus 2 cos... Let's write this as 2 cos theta plus 3. I'm vibing here, but I feel like this is what's going to happen. Because, right, what would we need? For our cos squared term, I need a minus 10 cos squared theta. So what would I need to multiply 2 cos theta by to get that? It would be minus 5 cos theta, right? So then I'd get minus 10 cos squared theta, and then I would get minus 15 cos theta. So then I would want to plus 8 cos theta, wouldn't I? To get minus 7 cos theta. So if I was to then add a 4, this would work out, would it not? Because the 4 times the 2 cos theta would be a plus 8 cos theta, and then 3 times 4 would be 12. Oh, grim. So that was quite tough to factorize, mainly because usually people prefer it when you have like a positive cos squared term. So if you wanted to have done that, you could have just taken a minus 1 out, factorized it like that, and then brought the minus 1 back in. I just did it like this because I know these questions, right? Like, how is this going to simplify nicely? It's if one of the brackets is going to equal a thing on the bottom, right? So that's why I was like, look, let's see if it works with that. But yeah, that was tough. Because now, obviously, we can do the old that cancels with that. We are therefore left with minus 5 cos theta plus 4. Let's hope that that's what they have, yeah. Because they have 4 minus 5 cos theta. So a bit of identities, a bit of factorizing. Hence or otherwise, solve the equation that. So, okay, hence or otherwise, you really should know that this means use the thing that you've just done, okay? The thing that we have just done is we've shown that that grim-looking thing on the left is exactly the same as 4 minus 5 cos theta. So in this equation, we have that grim-looking thing on the left, just instead of a theta, we have an x. In other words, the thing on the left is just 4 minus 5 cos x. That is then equal to 4 plus 3 sine x. And let's solve it. So we can cancel 4, can't we? So we're going to get minus 5 cos x equals 3 sine x. Let's divide by 3 here. So I'm going to get minus 5 over 3 cos x equals sine x. What can I do? Remember the identities, right? We've already used the cos squared plus sine squared. We've not used this yet. So tan is sine over cos, right? If you ever have some amount of cos equals some amount of sine, divide by cos. It's going to help you out. Because I'm going to get minus 5 over 3 equals sine over cos, which we know to be tan. So essentially, this has just simplified to that. and I'm looking for solutions between 0 and 360. So if you were to draw the tan graph, then what we do, let's draw a bit of the old tan. So it's going to kind of go like that. That was actually not too bad. That could have been way worse. So this is 90. So I'm going to need a few of these just to kind of show what's popping off here. Let's pop another one in there. Let's pop another one in here. Okay. We have asymptotes. This is 90. This is 270. And then basically it hits the x-axis at multiples of 180. So this jobby here is 360, and that is where my range ends, isn't it? So I'm looking for solutions between here and here. So it's minus 5 over 3 that I care about. So what I'm going to do is I'm just going to do a horizontal line at minus 5 over 3. So there. So that tells me that I am going to have 2 solutions in the given range. So tan, when you get this on your calculator, it's always going to give you solutions kind of from this first like branch almost. I'll show you what I mean. If I was to do the inverse tan of minus 5 over 3, here's what I'm going to get. So let's go here. Inverse tan of minus 5 over 3 gets me the following. If I remember how to use this calculator, it gets me minus 59.036 blah de blah de blah. So here's the thing, right? That's this value here, isn't it? That's your minus 59 blah de blah. That's obviously out of the range. But I can at least use this and then the symmetries of the tan graph to get the solutions that I actually care about. Each one of these chunks is 180 degrees wide. So to get from one chunk to the other, I just jump multiples of 180 from wherever I want to go, which is quite nice, isn't it? So all I would need to do here is I would go boom, plus 180 to get that, and then boom, plus 180 again to get that. So not too bad at all. So all I do here is just say the x values that I care about, and then I'm going to do ants to keep all of the accuracy. So ants plus 180, which gives me 120.96 blah de blah de blah, and then that's that, and then another just ants plus 180, literally press equals again, and that is going to get you 300.96 blah de blah de blah. So let's just kind of round them slightly. Let's go 3 sig fig here. So I'm going to go 121 degrees and 301 degrees. Question 13 looks pretty big. So we've got a sketch of a part of the curve with the equation this, and it's some cubic, and it says it's got a minimum turning point when x equals k. So that's the thing that's on the diagram with that vertical line. The region R is bounded by the curve, the x-axis, and that line. Show that the area of R is that. In other words, find the area of R and you can check your answer at the end. If it's not 256 over 3, you've messed up. So obviously we're going to need to find this value of k. How else am I going to get the area? How am I going to get where the minimum turning point is? Well, I need to differentiate and set it equal to 0, right? If you think about the tangent at a stationary point, it's going to be a horizontal line. That line has a gradient of 0. So if I differentiate this jobby over here, what am I going to get? I'm going to get 6x squared minus 17 times 2, which is 34. Maths, man. Plus 40. Okay, set this equal to 0. I mean, do what you want. Do what you want. Again, calculators help, so why don't we just do that? Menu, go down to equation func, polynomial degree 2, put your coefficients in. 6 minus 34, 40. Straight away it gives me my answers. I get an x equals 4, and I get an x equals 5 over 3. So we've got 2 turning points. The question then is, which is the one that I care about? Which is the k? Let's look at the graph. There's a minimum turning point at k, but there's one before that as well, which is a max, isn't it? So basically, the one that we want is obviously the second one. So it's going to be the larger x value. What's bigger, 4 or 5 over 3? It's 4, isn't it? So that x equals 5 over 3 is going to correspond to that maximum point up there. And then the 4 is going to be k, which is the minimum. So k is 4 here. Cool. So really, all that is left to do is just this integral between 0 and 4. So let's have it. Okay. So the area R is going to equal the integral between 0 and 4 of 2x cubed minus 17x squared plus 40x. Now the good news is one of these is 0, so that's going to make my life slightly easier when it comes to putting the limits in. But in terms of integration, add 1 to the power, so x to the 4, and then I've got the 2 divided by the new power. Add 1 to the power, so x to the 3, got the 17, divide by the new power. Add 1 to the power, x to the 2, got the 40, divide by the new power. Okay, so as I said, when I sub x equals 0 in here, everything's going to go to 0. So the only thing I actually care about is subbing 4 in. So 2 over 4 is a half, so that's going to be a half, and then I'm going to sub the 4 in, so 4 to the 4. Minus 17 over 3 times 4 cubed, plus 40 over 2 is 20, so 20 times 4 squared, and I really hope this is 256 over 3. So I'm going to go back into the normal mode on my calculator. I'm going to do a half times 4 to the 4 minus 17 over 3 times 4 cubed plus 20 times 4 squared. Yes! 256 over 3, mate. Who would have thought? It's still got it. Question 13 done. Quite a few questions here, isn't there? So the value of a car V can be modelled by the equation, that thing there. So it's exponential, got some e's in it. Where the age of the car is t years. Okay? So it just says, give me how old the car is. I'm going to tell you how much it's worth. Easy as. Find the initial value of the car. Okay? Well, initial is t equals 0, isn't it? Right? Obviously, age is t years. If its age is 0 years, that's basically like it being new, isn't it? So all you need to do is sub t equals 0 into this equation. So V is going to equal 15,700, and then you're just going to get e to the 0, essentially, plus 2,300. Now, anything to the power of 0 is 1. So you actually just have 15,700 plus 2,300 in this case. Sweet. So this thing here, add 300 is 16,000. Add another 2 grand, you've got 18,000 pounds. Not too bad. Part B says, given that the model predicts that the value of the car is decreasing at a rate of £500 per year at the instant when t equals big T, show that, all of that stuff. Okay, pretty grim, but essentially it's saying every time you're asked about like a rate of increase or rate of decrease, a rate is a derivative, okay? So if I was to do dv by dt, that would be the rate of increase or decrease of v, right? So as time changes, what is the rate of change of v? That's what a derivative is. So get the derivative. So how am I going to do this? Well, the 2,300, that just goes because it's just a constant term. Now, with ease, what I need to do is I need to bring down the thing in front of that t in that power. So I need to bring down the minus 0.25. So I'm going to have minus 0.25 times 15,700, and then the e doesn't change, so e to the minus 0.25t. Now, I am told that if t is equal to big T, this derivative is equal to 500. So, now it says decreasing at a rate. Okay, so here's the thing. This is negative, isn't it? But so it would mean it's decreasing. It's got a negative derivative. So the rate of decrease would just be the positive version of that, wouldn't it? Like if it's minus 4, that means it's going down by 4 kind of thing. Therefore, 0.25 times 15,700 and then e to the minus 0.25 big T is going to equal 500 because that's the rate of decrease when t is equal to big T. So I just hope that this thing in front, so 0.25 times 15,700 is 3925. Therefore, 3925 e to the minus 0.25 big T should be equal to 500. Is that what they want? Yes. Cool. It then says, hence find the age of the car at this instant, giving your answer in years and months to the nearest month. Okay, we just need to solve this equation, don't we, right? Divide both sides by this to isolate the e. So I'm going to get e to the minus 0.25t equals 500 over 3925. Let's just see if this simplifies at all. 20 over 157. Nothing too crazy, but it's worth having. Okay, so how do I undo e's now? I need to take the natural logarithm. So natural logarithm and e just perfectly cancel each other out. So I'm going to be left with minus 0.25t equals the natural log of 20 over 157. Therefore, t is going to equal ln of 20 over 157 divided by minus 0.25. Stick this into your calculator. Let's see what we get. So I'm going to do ln of ants here, actually. Over minus 0.25 gets me this. 8.242 blah de blah de blah. Let's round this to 3 sig fig for now. So 8.24. What are we then asked for? We are asked for, so to the year and the month. Okay, so 8 is clearly 8 years. Now, the months is going to be to do with this 0.24, isn't it? But it's not as simple as just like saying second month, because we need to think, well, there's 12 months in a year, right? So if I was to do 0.24 times 12, what would that get me? That would get me 2.88, right? So it's almost like I've got 8 years and then 2.88 months. But we're asked for like the month in, well, the nearest month. So basically, to the nearest month, it's going to be 3, isn't it? So it's going to be 8 years and 3 months. So I suppose that's why there's so many marks. It's like getting the t, which is a bit grim, but then it's like converting all of that into years and months. That's why I looked back at the question, because I was like, I want to see if there's a specific way they want this answer. Like a lot of the time they might say, oh, find the year in which this happens, and then it's something else. So you've got to be careful there. The model predicts that the value of the car approaches but does not fall below A. State the value of A. Yeah, okay. So look at V. It's made up of 2 parts. It's made up of 2300, which is obviously just always 2300, and then plus 15,700 times e to the minus 0.25t. So what's that first term? First of all, is that term ever negative? It's not, because e to the power of something is never negative. It goes very close to 0, right? So if I was to just generally sketch a negative exponential, in other words, like e to the power of minus something, what happens is it goes crazily close to 0 like that, but never quite hits it. So if the first thing goes crazily close to 0 but never quite hits 0, and then the second thing is always just plus 2300, then surely this value A, it's going to get super near 2300, but never quite hit it and never go below it. Sweet. State one limitation of this model. Okay, I mean, there's usually quite a few acceptable answers here. Let's have a look. So what's going on? I mean, first of all, this model it's saying that the value is always going down, right? It's kind of got this negative exponential. It's probably true in most cases, but what if it was like some kind of rare or vintage car that you were keeping in perfect condition in your garage and not driving or anything? Then it might go up, right? So maybe the car is rare and the price will actually go up. Who knows? Who knows? That could happen. You know, you could also maybe say that there will be other things that affect the price, not just time, right? Like, similar thing. I mean, if I have one car and I just keep it in the garage in super good condition, and then someone else has the same car but absolutely beats it, does 50,000 miles on it each year, you would probably expect mine over the same time period to keep a higher value. So there are a lot of usual factors at play in the real world. Question 15, we should almost be done, says, given that... So what does that mean, by the way, that n thing? That means that n is a natural number. In other words, it is a positive integer. Prove that n cubed plus 2 is not divisible by 8. Ooh, okay. So usually with these things, like, the answers are algebraic. In other words, you want to develop the algebra in some way. that then you get a line that makes it obvious, like, oh, that's that, or whatever. Now, I can't really develop the algebra much here. There's not much I can do to n cubed plus 2. So maybe one thing I could do is I could split it into like even and odd numbers, right? N is either even or odd. But I can express an even number. So if n is even, then I can express n in the form like 2 times by some other integer, 2k for example. This lets me then develop the algebra slightly. So what would n cubed plus 2 be if n was equal to 2k? Well, it would be 2k cubed plus 2. Now, this is useful because I can simplify 2k cubed. This is going to be 8k cubed plus 2. Okay, I think I've got it. This thing here is a multiple of 8, isn't it? So 8k cubed is clearly a multiple of 8 because it's 8 times something. It's 8 times a number, right? So my explanation would kind of be the following, right? 8k cubed is a multiple of 8. Cool. So then if you take a multiple of 8, where is the next multiple of 8? It's going to be 8 later, isn't it? So if I have a multiple of 8, add 8 to it, that's going to be a multiple of 8. But I'm only adding 2 here, aren't I? So I've got a multiple of 8, I've hit that multiple of 8, and then I only add 2. So that's definitely not going to be a multiple of 8 because the next one is over here. So multiple of 8, and then, adding 2 to that is not going to give me a multiple of 8, is it? So that's a good way of showing something isn't a multiple. If I have a multiple and then plus some number, that can make it not a multiple. So I've shown that if n is even, this thing is a multiple of 8. So the only other thing I need to do now is show that this happens if n is odd. So how do I express an odd number? You express an odd number as an even number, so 2k, and then plus 1. If I have any even number and add 1 to it, then it's going to be odd. You could also do minus 1 as well, couldn't you? So we can do a similar thing. We can say, well, what would n cubed plus 2 be? It would be 2k plus 1 cubed plus 2. Now this I can use the binomial kind of expansion for. So the coefficients are going to be 1, 3, 3, and 1, which you can get from your calculator or Pascal's triangle. And then I'm going to have 2k cubed. I'm going to have 2k squared times 1. So 2k squared, right? And then I'm going to have 2k times 1 squared. And then I'm going to have 1 cubed. So all of these are going to be added together. So that's going to get me 8k cubed. I still need the plus 2 on the end, don't I? So plus 2. So that's going to get me 8k cubed. And then this thing here is going to be 4k squared. Times that by 3 to get 12k squared. This is going to be 6k. And then 1 add 3 is going to be 3. Right. So clearly, I've not really got any easy multiple of 8s I can see here. I mean, this is a multiple of 8, but then I can't really do anything with everything else. But there is something I could do here. This 3 is making me think that this thing's going to be odd. So the way I could show that is I could take a factor of 2 out of all of this stuff, because that's all even, isn't it? Because that's going to be 2 times 4k cubed plus 6k squared plus 3k. So no matter what this is, this whole thing's going to be even, and then I've got a 3 chilling on the end. So here's the thing. I've got even plus odd. Well, what's that going to be? That's going to be an odd number, isn't it? So this whole thing here, this expression, is an odd number. Can an odd number be a multiple of 8? No. So it's an odd number, and therefore not a multiple of 8. So it's always something to look for with proofs. It's always like even numbers, odd numbers, because that's just a pretty key part of the syllabus. So even if they don't explicitly say anything about even and odd numbers there, if you're a bit stuck and you're like, oh, what do I do? Think about even and odd numbers and it might get you somewhere. 16. I'm hoping this is the last question because I am starving. So it says 2 non-zero vectors A and B are such that the modulus of A plus B is the same as the modulus of A plus the modulus of B. Explain geometrically the significance of this statement. Right, that's actually pretty grim, you know. So if I had 2 vectors, right, vectors have like a size and a direction. They're some line, right? So this thing here, these lines on either side mean like the size of it, or the modulus, or the magnitude. So for example, if I've got a vector A, like that, the size of it would be the length of this line. So imagine I had a vector A and then some vector B. So some other vector B going in a different direction. So the modulus of A plus the modulus of B. So this is the modulus of A, the length of this here, plus the modulus of B, so the length of this thing here. That would be that plus that. But then the modulus of A plus B would basically, what I'd first do is get A plus B as a vector and then work out the size of it. So A plus B as a vector is just going to be kind of the resultant of these. So if I start here and end here, that's A plus B. But that as a vector is just going directly. So that would be that, essentially. So the modulus of the vector A plus B would be all of this. So in this case, it's not true, is it? Because if I take this length and add it to that length, that is not going to be the same as that length. So in this case, A plus B is definitely not equal to A plus B. Because, you know, two sides of a triangle are not going to equal that other side. So how can this be true? What is the only way in which, if I go like A plus B, and then that's exactly the same as A to B, how is that going to happen? I think the only way of this happening is if I have A, and then I have B, and it's in exactly the same direction. Because now if you think about it, this is B, this is A, so A plus B is going to be obviously just this whole length. But then what would the vector A plus B be? Well, it would start here, and then it would go all the way to there. It's exactly the same thing, isn't it? And in this case, yes, the size of this red line is going to be exactly the same as the size of the yellow line plus the size of the green line. So the geometrical significance of this is going to be what? Well, A and B have to be in the same direction. That's the only way that this can happen. So A and B are in the same direction. And I mean, it's only 1 mark. That's actually quite difficult, to be honest, but that's going to be the answer. So part 2 says two different vectors m and n are such that the size, the magnitude of m is 3. So I don't know, maybe m could look like that. And m minus n equals 6. Okay, grim. The size of m minus n is 6, right? The angle between vector m and vector n is 30. Okay, so let's get that down. If this is m, then if the angle between m and n is 30, then maybe n could be something like that, where this thing is 30 degrees. Cool, okay. So this could be n. It then says m minus n equals 6, and then we have to find the angle between the vector m and m minus n. Okay, so you can kind of make triangles with vectors, just like I did in that one before. Think about what, like, the journey of m minus n would be. Like, if m is going up here and n is going up here, if I was to say, give me the vector m minus n, that would essentially be me going across the vector m and then across n, but going the opposite way because it's minus n. So what I can do is I can put n, I can put it so that it starts at the end of m. Because then think of the journey here. I could do the following. I could go m, which takes me from here to here, and then minus n, which goes the other way, right? So essentially the vector m minus n is just the vector taking me from here to here. It's just start point to end point, isn't it? So this here is the vector m minus n. We're told that the size of this vector here is 6, right? Okay, so we're getting a bit of a situation on the go, aren't we? Because we know the size of vector m is 3, so this is going to be 3. Just going to move this out of the way for a second. So I've got 3, 6. And what is the angle that I want in this case? The angle that I want is the vector between m and m minus n. So that's going to be this, right? Cool. So how can I get this angle, right? Let's have a think. Can I think of kind of sizes or anything like that? Well, first of all, I know that there's a 30. Where is that going to be? So the angle between M and N is 30. Remember that. So that would actually mean that this angle is 30 as well. Because this is N just in a different direction, right? So if that's 30, I think I've got enough information here, haven't I? Because I've got angle, angle, and then side, side. I can use the sine rule here. Now, I can't use the sine rule to directly work out this angle here, but I can use it to work out this angle. Call this angle alpha, whatever. Then I can use the sine rule because it's the opposite angle inside. So if I was to say sine of 30 divided by 6, right, it's the opposites, equals sine of alpha divided by 3. Okay, so I can then work this out, because if I multiply this by 3, I'm going to get sine 30 over 2 equals sine alpha. Now, sine of 30 is a half, so sine of 30 over 2 is a quarter. You could have put that in your calculator, though, so that's no worries at all. So sine alpha equals a quarter. Therefore, alpha is going to be the inverse sine of a quarter. So what's that going to be? Sine to the minus 1 of 0.25 is 14.477, blah. So that's that, but how would I get the angle that I want, theta, for example, from this? I need to do 180 minus the 30 minus the alpha. So my final answer here is going to be 180 minus 30 minus alpha. So I've got this alpha in my calculator as ants, haven't I? So if I do 180 minus 30 minus ants, that's going to get me my answer, which is 135.5 blah. Let's stick with 4 sig fig here. So let's go 135.5 degrees. Yeah, to 1 decimal place. Fantastic. And I believe that is it. So, very, very grim paper. 16 questions, a bit longer than I expected. I'm pretty knackered, to be honest. If you would like a full course, if anything there, you didn't understand, if you want a full course going over every single concept in detail, you go over to AI Tutor. You're going to have lessons done by me. So if you can't stand my voice, definitely do not go. But if you would like full lessons, interactive questions, practice papers, all of that stuff, head over and you will be smashing exams like this in no time.